Hi there, my name is Brett Williams. I'm a tech transfer specialist for the U.S. Forest Service Southern Area, Fire and Aviation Management, and working group lead for the Eastern Innovation Landscape Network, or EILN for short. I'd like to start by thanking Joe Marshall, Jonathan Stober, and the other co-organizers and sponsors of this conference for inviting me to speak on this topic. I wish I could have been there with you this week, but unfortunately I was not able to, so I hope it has been an enlightening week of presentations, networking, and discussions that I usually love to be a part of. I have the pleasure of being the last speaker of the conference, and the topic I'm about to present isn't specifically focused on fire in Eastern Oaks, but the fire science co-development concepts should be broadly applicable and I hope interesting and useful for you. I decided to use the little cameo screen in the corner so you can see me to make this recording slightly more personal, but I may move around a bit during the presentation to keep from blocking portions of each slide. And with that, we'll get started. So, why do we need accelerated innovation in prescribed fire science and technology? And to this crowd, it's probably obvious, and you may have your own answers, but as we're all aware, prescribed fire is the most cost-efficient and effective tool for managing hazardous fuels and improving ecological conditions within our eastern upland ecosystems. Yet, fire managers are experiencing more and more novel fuels and novel fire environment conditions due to a number of factors, from extreme weather swings to invasive species, rapid urbanization. We're just living in a kind of no analog novel present. um, so fire management has evolved over time. So our tools and our technology need to continue to evolve as well to meet these increasingly dynamic challenges. So what we really need are tools and models tailored specifically for prescribed fire, uh, for fire planning and fire management. And as you're all aware, or most of you that work in fire, our current fuel models are well known and widely used, but they're abstractions of reality and relatively simplistic. And our operational fire behavior models, they're very fast. They're used for a wide range of applications, things like Flam Map, Farsight, Behave Plus, but they're simplistic. They have a lot of assumptions that don't work for prescribed fire. They're close course and resolution, and they were really designed for suppression decision support for initial attack or multi-day fires where you need a few day model run on fire spread or fire intensity, and but maybe more simplistic than what we need for prescribed fire. And then everyone kind of knows that fire effects monitoring, it needs to be done. We need to be doing it. It's important for feedback and adaptive management, but still it faces a lot of challenges, including staff and time capacity, inconsistent methodology, sampling bias from crew to crew, and typically low sample size unless you're using a real rapid assessment method. So to address some of these needs for more prescribed fire specific tools, expand our toolbox and the models that come along with that, the Department of Defense or Department of War, I'm going to be calling it Department of Defense going forward, but DoD, U.S. Forest Service in the eastern and southern area, U.S. Fish and Wildlife Service in the southeast, we all partnered in 2023 to establish the Eastern Innovation Landscape Network. I spent most of my career with the Air Force as a FMO at Eglin Air Force Base and a number of other bases in Florida and Georgia. And Eglin was kind of a living lab for co-production, and we really engaged with the research community, and I learned a lot of lessons there that I've been able to bring into this effort. Our vision statement is networked interagency co-production, fostering deliberate, accelerated wildland fire innovation. Kind of a mouthful there, but it really gets to the point of our mission here. So aside from those three primary agencies of DoD, Forest Service, Fish and Wildlife Service, we have currently about 20 other federal, nonprofit, tribal, and university partners. And I've also been in talks with a number of potential state partners as well. We'd love to bring into the fold into the future. We initially designated 9 innovation nodes, is what we're calling them. They're shown here on the map. There's 3 from each of the primary agencies. These are the living labs for fire science co-production, co-development. We also recently added 5 other Department of Defense installations for additional testing and to refine our tech transfer approaches for specifically the terrestrial LiDAR fire effects monitoring that I'll talk more about here in a minute. The traditional fire science research paradigm has been for researchers to submit a proposal to a funding source, let's say JFSP or National Science Foundation, etc. That proposal gets accepted, and then the researchers reach out seeking willing management partners or management units to conduct their research on. They may come implement their research at that site. They're out of sight and out of mind of the manager at times. And then at the end of the project, if the manager's lucky, they send them at least a publication or kind of a summary of their results. So the EILN mission is really at its core to change this fire research paradigm. And for fire research to become more of a partnership between fire practitioners and end users throughout the life cycle of that research project, from conception, coming up with the actual problem statement, all the way to publication and outreach and distribution of lessons learned. And we hope this paradigm shift in how fire science is planned and implemented will ensure that end products and tools are useful, or they're usable, and they're used based on that practitioner involvement and feedback from the very beginning and throughout that life cycle. So getting back to the tools sum, to expand this prescribed fire toolkit, the EILN leadership team decided the initial tools and models for EILN evaluation should focus on 3-dimensional fuels characterization to support next generation fire behavior modeling, and for prescribed fire planning, fire effects monitoring, and decision support, as well as these new next-gen coupled fire atmosphere fire behavior models, such as QuickFire and the Fire Dynamics Simulator, or FDS, and DSS, or decision support platforms, such as Burn Pro 3D, for prescription development, burn prescription development, improved smoke and ecosystem modeling, after-action reviews, and training. So 3D fuels includes, at the moment, airborne LiDAR, terrestrial LiDAR, as you can see here, and then those get integrated into fast fuels. This is a CONUS-wide, wall-to-wall, 3-dimensional fuelscape built from FIA data and imputed FIA and landfire data to develop a realistic fuel bed that feeds into QuickFire and other next-gen models like FireTech and FDS. They need these 3D fuels data sets to really run accurately and precisely. So ultimately, what we're trying to get to is taking those fire behavior outputs from QuickFire and these next-gen models. You can see here there's a model example of QuickFire from a aerial ignition burn on Fort Stewart in Georgia. What we're really trying to do is predict fire effects. So what's the effects of the fire based on that fire behavior model on the ecosystem, the trees, the vegetation, the fuels, to be more accurate in our modeling of smoke dispersion and transport with tools like and models like QuickSmoke that are in production, and then to feed into ecosystem process models like Landis-2 for predicting natural community development under various fire or fuel treatment regimes. And there was a publication recently of bringing QuickFire into Landis-2 and doing some kind of long-term fire regime modeling into the future. That was at Fort Bragg, one of our other EILN innovation nodes. So let's talk 3D fuels for a second. EILN is currently innovating around practical uses for airborne LiDAR, or ALS, as well as terrestrial LiDAR, or TLS. And while airborne LiDAR is becoming more and more accurate at capturing canopy structural characteristics like basal area, trees per acre, volume estimates, etc., TLS is being evaluated for both improving canopy measurements and characterizing the subcanopy, the surface fuels, where fire behavior is typically in the eastern U.S., unless it's a jack pine or pitch pine or these stand replacing fires. Really, we need to get to subcanopy surface fuels to be able to parameterize fire behavior. So the EILN is keenly interested in TLS for the potential it holds to save time especially with fire effects monitoring, reduce sampling bias, and gain efficiency from a single push button scanning versus traditional field crew-based fuels monitoring methods, as you can see here in the photo with the Leica BLK 360 being that single push button. Thanks to USGS Aeros, and the New Mexico Consortium, TLS scans taken with the Leica BLK 360 can be uploaded to USGS servers and run through a number of scripts and code to produce I think they're up to over 240 direct TLS metrics, which are retrievable for a given scan or scans by automated email requests through the Intellimon viewer interface. And I talk about the Leica BLK 360. We're scanner agnostic, but that's been the most cost efficient and scanner that produces the metrics and returns we need, point cloud returns that the modelers have been really working around, but opened other scanners into the future. So in addition to over 240 direct metrics provided by running the TLS scans through code at USGS, Aeros, and Intellimon, the various forest strata can be segregated, and then regression and machine learning statistical methods can be applied to compare TLS scans and field training data to produce modeled metrics, such as the ones listed here. A lot of these should be more familiar to you. The direct metrics aren't as intuitive, but we're hoping to make more use of those into the future. So soon after a scan is loaded into Intellimon, the scan becomes visible in an application called Points to Pano. This is a UC San Diego application which visualizes TLS scans, provides a few basic metrics about the stand and trees like tree diameter or basal area, and it allows for comparison of multiple TLS scans over time. So if you have, I didn't show it here, but you can split screen, and if you've got two different or more scans, you can look at them side by side, turn the scan simultaneously, and it provides both the point cloud as well as the overlaid color image. So it's sort of a living or a photo, a 360-degree photo as well. And Points to Pano was developed specifically to meet a direct request by fuels and fire managers to view and assess TLS point clouds. They said, hey, this is great. We can get all these metrics from Intellimon, but we'd really love to be able to visualize it for leadership or for our own understanding, and to be able to look at the before and after effects of a treatment and so forth. So let's turn to next generation fire behavior models. The EILN has been extensively testing and evaluating these coupled fire, atmosphere fire behavior models. Specifically, or most of our time's been iterating around quick fire, and we're getting these into the hands of fire managers, both test driving the user interfaces, but also outputs and getting feedback on the model itself. It's a fast-running wind model paired with a cellular automata fire spread model that resolves heat release, energy balance, and wind dynamics to account for fire's interaction with the atmosphere and complex ignitions typical of prescribed fire. These are, Farsight, Flam Map, Behave Plus. They just can't get there from here. So we're working through quickfire to get there. The 3D fuel bed and topography are provided by fast fuels, while weather inputs, fuel moistures, and ignition patterns are either user-defined or pulled from existing data sources, such as gridded winds as an example. You can now bring in gridded wind tiles as a way to parameterize your winds. Quickfire allows fire managers to game out scenarios and answer questions concerning the actual physical mechanisms at play from either the fuels, topography, weather, or ignition patterns. So example questions include that you could ask the model, or what prescription will most likely achieve my burn objectives, or what fuel treatments will be most effective for reducing wildfire risks. This is an example of variable density thinnings and their effects on fire rates of spread and fire flame lengths and so forth. What firing pattern will provide my desired fire behavior? Is it going to be flanking fire, backing fire, point source? So specific questions for oak forest management might include what prescription will maximize oak regeneration while reducing encroachment of mesophytic species like yellow poplar and red maple? Or what firing pattern will most likely result in an open woodland forest structure? Or if quickfire is running an ensemble, what will this oak forest look like in 50 years if I burn on a 4-year mean fire return interval versus a 10-year mean fire return interval? On this. So quick-fire outputs can then be fed into a companion model, QuickSmoke. This is a Lagrangian random walk model that resolves atmospheric and fire-induced turbulence, predicts the dispersion of gases like carbon monoxide and water, as well as PM 2.5. It accounts for gravitational settling of particulate matter through deposition across time and space. So this allows users to game out the effects of variable atmospheric conditions, variable mixing heights, inversions, stability, so forth in the atmosphere, as well as ignition rates and patterns. It can take into account heterogeneous fuels, and then the effects of those fuels on ignitions and or fire behavior, buoyancy, so forth. So it allows some scenario gaming and planning for fire managers to be able to really understand how to mitigate their potential smoke impacts. So now I've introduced some of the tools and models EILN's been innovating around with fire practitioners. Let's take a closer look at our co-production strategy. So our strategy has been a user-centered design approach that's been deployed using multiple methods. Some of those methods include terrestrial LiDAR training, so actually getting the tools in the hands of managers, fire manager focus groups, or what we call road shows, in which we get managers hands-on with QuickFire, Burn Pro 3D for focus test and evaluation. We've done this at Fort Stewart, the Oconee National Forest, Piedmont National Wildlife Refuge, Joint Base McGuire-Dix Lakehurst, and New Jersey Pine Barrens. We did a fire science technology workshop at Choctaw Nation of Oklahoma. This past December, we did a pre-workshop to the Association of Fire Ecology Congress in New Orleans. And you can see some of those events here. Another key strategy the EILN has been supporting and participating in large prescribed fire research burn campaigns. Funded by DoD, CERTIP, and ESTCP, and last year a little bit by NASA FireSense. And these campaigns have predominantly been on DoD installations such as Eglin Air Force Base and Fort Stewart. You can see the IAP here from Fort Stewart, but the EILN supported a smaller campaign focused on smoke model validation at Oconee National Forest in central Georgia this past April. And plans are in the work for a large campaign next spring at Cape Canaveral, Florida, in partnership with NASA FireSense. More recent strategy has been EILN participation in what are called DoD or their CERTIP and ESTCP funded technology prize challenges as where the EILN folks serve as subject matter experts and judges. High-risk fields in the military and industry have been using simulators and VR immersive experience for years, so why not wildland fire and prescribed fire? So EILN last summer participated in a VR tech challenge. We asked vendors to bring quick fire model runs into VR for training. And worked in Central Florida Tech Grove, set it all up for us. And now we're partnering with NAFRI and PFTC and Los Alamos National Lab to design various prescribed fire ignition scenarios for these vendors to build into a virtual prescribed fire training experience. And we've got a few other tech challenges we're working through now on some autonomous ground-based vehicles, as well as three-dimensional fuels for sub-canopy and surface fuels. So I'd like to wrap up with the initial co-production lessons we've learned thus far through EILN. The biggest one being the importance of building relationships. It's just, maybe this is common sense, but fire managers, fire management in general requires a lot of trust. You're doing a dangerous job oftentimes. And so there's a kind of a getting to know you period. And so the faster you can generate trust, open communications, build those relationships, the faster you're going to get into that co-production mode. And fire managers need to know that researchers understand their operational constraints, and that if researchers show up on a burn, that they're going to follow chain of command, wear PPE, act in a safe manner. It's very crucial up front to spend some time on thought on defining your potential use cases, user groups, who will actually be turning the crank on these tools and models. It's really important to identify and nurture the right end users and early adopters within your organizations and networks. There's folks that just are into it and excited about it, those that aren't willing, those that are willing to spend the time and so forth. So focus down on those folks and really keep them engaged. This may be obvious, but to a lot of you, but fire management is seasonal. So practitioners' availability for workshops, field campaigns, etc. is seasonal as well. Summers, for instance, are typically my catch-up time as Western fire season keeps everyone busy. And as you would expect, in-person engagements are preferable for building relationships and trust. And I highly recommend fire researchers do what they can to obtain basic fire line qualifications, both to breed trust with fire managers, but also so they can operate more independently on research burns and take the pressure for facilitators off the local unit. Many of the fire research staff at U.S. Forest Service Athens Prescribed Fire Lab in Athens, Georgia, have fire line qualifications. They'll even go help the Chattahoochee and Oconee National Forest burn operationally just to continue gathering intel on management relevant fire science questions and to foster trust in relationships. And finally, I've found that many fire practitioners are nervous to speak at length with PhDs. Since researchers are often seen as experts placed on a pedestal within their academic field. So that relationship tends to flip some degree on the fire line as the fire practitioners now become the experts, which in turn breaks down barriers for relationships to flourish. Humility on both sides goes a long way as well. So in terms of outreach, we have a EILN website on the Forest Service side, a fact sheet, a website on the DoD or DOW side, and a number of articles I can share by request. The Southern Fire Exchange has been a huge outreach partner and continues to amplify our successes. And we're also recently received a JFSP grant to study the sociological aspects of EILN. This is through Northern Research Station. They have some sociologists and what factors have contributed to our success, how to replicate and export this collaborative co-development model to other geographies. And this should be a QR code for our U.S. Forest Service EILN website. And with that, will the real Brett Williams please stand up to answer any questions?